tracking the white van.
Started tracking the white van.
All right, hello AI Tinkers, and welcome to One Shot. This is our global stage where we bring people from the community and give them a chance to go a little deeper, look under the hood, see if we can learn something from their projects. And today I am super excited. I'm thrilled to have you. This is Maxwell, a software engineer at SpaceX and the creator of Dispatcher, which is a side project that's incredible. It's an AI-powered drone, voice control. I saw it on Twitter, and then I ran into you at the hackathon, and I saw it right away. I knew exactly who you were, and and then you were tracking me moments later on your laptop, so it was awesome. Thanks, Maxwell.
Yeah, it was really nice to meet you at the hackathon. I didn't think you would be there, but yeah, I was glad to bring it out and show it to some people, and the reception seemed to be pretty good.
It's a pretty amazing project. There's a lot of components to it, and I'm just excited to dig in. So why don't we get to your background and all that later and just dive right in?
Sure. What's that? You want me to play the video?
Yeah, let's do that.
Drone dispatcher ready. Over.
Can you go check how busy the nearest Trader Joe's is?
En route to the nearest Trader Joe's.
Drone's going a little slow. Can you increase it to 10 meters per second?
Speed set to 10 meters per second. Continuing to Trader Joe's. Drone has arrived at Trader Joe's. Traffic looks moderate.
You actually overshot a little bit. Can you back up 50 meters and then take a look?
Backing up 50 meters. Positioned correctly. Checking the area now. Trader Joe's parking lot is visible now. The parking area shows light to moderate activity.
Start tracking the white van.
Started tracking the white van.
If the drone's power below 70%, please send it home.
Drone's battery below 70%. Returning home. Area appears clear and suitable for landing. Proceed with the return to home function now.
Awesome. Thank you. Okay, super cool. Obviously, a lot going on there when you consider all the pieces and the telephony and everything else.
Yeah.
But why don't you just, for the sake of understanding all that's there, from the moment someone says something like back up 50 meters or increase speed, what are all the pieces that are touched along the way?
Yeah, so whenever I like to explain this to people, I break it down into 3 components, and that's basically the architecture of the system. And the 3 biggest parts are you have a user interface that someone can talk to and interact with. You have a cloud backend that runs all the smarts, all the AI, some of the heavy workloads. And then you have the drone itself. And what happens when someone asks for a command, they go through the UI. Right now, we currently have them press the spacebar, and then that allows them to start talking. From there, your voice goes to the AI backend where it's processed, turned into text. The text is parsed into a large language model. And then from there, functions are called, and then the drone action appears, and then you see it happen on your screen like magic.
Okay, so these function calls are then, or something, do you have a DSL or something in mind with a set of functions that you can do? You've got a gimbal and a camera that can move. What are the actions that can happen? What are the tools, I guess?
What's a DSL?
Like a domain-specific language for your...
Oh, I see. Yeah, so early on in the project, the first thing that I built was that interface between the drone and an LLM. So the interface is really similar to what a web UI would look like. So as long as you build out the major functionalities, like moving the drone, pointing the camera, once you build out that interface, then you're able to interact with it. I first built the web UI, so everything you can do, tell the drone to do over voice, you can tell it to do on the UI.
Okay, so you build a basically push button interface, and then now you have an LLM that just translates to that.
Correct. Yeah. So there are a couple of things that you can't do over the interface, but you can do over voice. However, it's that the general idea of an abstracted interface is what allows this to happen.
Okay. Then there's other pieces. I know from talking to you the other day that you've got an NVIDIA GPU running on the drone. So let's talk about the hardware components.
Sure.
Like, this is not an off-the-shelf drone for one thing, and you've got a GPU on there. Let's talk through all the hardware. Like,
Sure.
what is there?
I'll share what I'm willing to share, but the high-level overview is I'm treating the drone like an IoT platform. It is basically just a flying Linux computer.
Yeah.
And in order to get it to have unlimited range and not be constrained by that, and like a radio link, you just send everything over IP, right? So there's a 5G module on board. Eventually, I would like to get Starlink on it. Like, imagine it just flies off.
Yeah. I think you might know somebody who could help you.
Yeah, I don't know. Maybe I'll grab one off the line or something. But I think the main thing is the compute on board has to be just powerful enough to run the real-time stuff, as well as communicate with the more powerful AI back.
These are the real-time. You mean like for tracking when we saw track the white fan and there's a square, that's all local.
Yes. So stuff that has to happen real time, because even if let's say the models in the cloud were instantaneous, that latency between 5G and the whatever API calls you're doing still takes some time. So stuff that needs to be close to the camera needs to be run real time. So tracking is one of those examples.
Yeah. Did you have versions of this that were completely over the wire and were pretty crude and slow, and then you kind of evolved to that more real time? Did you know from the beginning that?
Right. So I think the model that I went with, because I used to build a lot of these pre-systems at my previous place, Paladin, and I think from that base, I already knew what to do and what not to do. So when I began to architect this system, it was like, I'm gonna start from scratch, but I know the lessons that I've learned along the way and some of the things that you shouldn't and should do to make the system more extensible and easier to use.
Okay.
Yeah.
Is it doing like a web RTC over this 4G connection, or is it just doing requests like socket, like the HTTP requests, like you would call, like if you're building a crude web app or something? Like, are you getting to that level of like sophistication, I guess, for the latency?
I think for now, I think you saw in my code, but a lot of the message passing, if it's not video, I try to use MQTT or really any.
What is MQTT?
Oh, MQTT is a IoT-based messaging protocol. The real seller there is that you're able to control the quality of service. So you can, I think it might, I'm not sure if it's built on UDP or TCP, but being able to specify that quality of service is really important for a low bandwidth application like drones, where you need to, there might be a lossy connection, especially since it's flying and reconnecting with cell towers.
Is that a piece that you're comfortable showing us the code for, or is there some piece of it that would be, for someone looking to hack on drones and voice control, or just voice control in general?
Let me see what I shared with you guys for the hackathon.
Okay, cool.
Where's my mouse? So here we can see one of the message receivers for MQTT. So MQTT allows you to do kind of event-driven stuff, and every time that a event shows up from MQTT, the message is really simple, like JSON format. And from there, you can specify commands like creating a tracker, changing the tracking mode, telling the gimbal to stop, zoom in or zoom out. So because it's over and it's like it works over a lossy connection, you can specify quality of service to retry until it happens. And one of the really cool features is that you can have send a message when you connect called like a kill message, or like the last will message. So like right before you die, it sends a will that says that you can tell the user that the drone has died with like something's actually gone wrong over that connection.
Interesting.
Yeah.
That's really cool. So it's basically a best effort communication protocol for IoT with some bells and whistles like that.
Correct.
And you can use it is it primarily used in IoT systems, or there's wireless or some other?
Yeah. So it's lightweight when you want it to be, and it's a little heavier and has some retries when you don't want it to be. So when like I used to use REST API for everything, and that still works great. But like I've seen over a lossy connection, this is probably the best way to go.
Really? Wow. Yeah. Cool. Okay. So if you're doing anything with like basically a 4G card of any kind for whatever, security camera, anything, any system that has a protocol of any kind, you're in control of the protocol, I assume. You define the messaging, like this move gimbal, whatever. Yep. It's just the transport. Okay. That's cool. And what is it implemented in? Like what platforms can you use it in?
No, funny you should ask. So MQTT is supported by all major languages. Oh, wow. I think it's supported by, there's a couple of people who support it. One of the really helpful things was EMQX. They host a broker. And actually, hold on, maybe my keys are in here. Yeah, you might have to redact that. But They host a broker.
Yeah.
You can host it yourself, but to get started, what I was using was their online client and their broker, and that allows you to send test messages. It takes like 10 minutes. You can learn the protocol pretty quickly.
Yeah, very cool.
Yeah.
Neat. That's great. All right, so back to like the van tracking thing. You're running some kind of vision model or something to do that, right?
Right.
And it's got to be local because of the speed, right?
Mm-hmm.
What are you doing there? Is that like an open source thing or something you trained or how?
Yeah, so that was the previous generation before when I made the video a couple months ago.
Yeah.
And grounding dyno was the main thing that was used. If you're like active in the computer vision space, you know that grounding dyno was this paper released like 2 years ago that is really good at open set tracking and referring expression. That's where the grounding comes in.
Okay.
And in order for you to track a white van, you basically take that message, white van on the driveway or the white van on the right, and it'd be able to put a bounding box around it. And then you pass that bounding box to a lower level algorithm that can do the tracking.
Okay.
But the object identification would be done by grounding dyno.
That seems like a pretty heavyweight vision model thing to be able to do if you're taking like context, like the one in the driveway, right?
Yeah.
Okay. But you're doing that locally on device, even that aspect?
No, the grounding dyno would be ideally deployed in the cloud for the purposes of the demonstration and just prototyping. I was having it run on my laptop. And without acceleration, just running on a CPU of a MacBook Pro M1, it was like 30 seconds for a 1080p frame.
Okay.
So the van has to be very stationary in order for this to work.
Yeah. Okay. Right on. You're not gonna win any wars with that or something like that. Yeah.
No.
Yeah. And then you replaced it with something faster.
Correct.
That's where you put the GPU on device, is to do that.
Mm-hmm.
Okay.
Yeah. So by separating some more of that compute and making it front load the easier task on the drone, you can have a faster latency.
Yeah. Okay. That makes sense. That's really cool. So it's neat to see splitting the problem up where we talk a lot about edge, and why it's useful and this and that, but here your resource constraints kind of force you to be on the edge in this case, right?
Correct.
Because latency, the context of which you're running this.
Right.
That's pretty cool. But
it's actually really interesting where right now the hardware that I'm running is pretty new and like one of the Orange series that are more expensive, but there are more powerful chips that are just as or more power efficient than newer generations that are able to run large vision transformer models on device.
Wow.
So the constraint here was also cost.
Okay.
I'm funding this by myself, but if you were able to do this, they could feasibly run on the drones themselves with no cloud compute.
How much does that weigh, the unit that you're using?
I'm not exactly sure, but weight is one thing. The other thing you have to contend with is power draw. So every watt you use for compute is a watt you can't use for flying.
Okay, and its batteries are heavy.
Correct. Yeah.
Okay, that makes sense. Interesting, cool. So what are, like, just sort of backing up from the whole project, you had hardware, you had software, you had the LLM interactions, you had latency in dealing with splitting up the problem, like IoT, low-level stuff. Like, what were the biggest challenges that you contended with overall?
Yeah, so actually with being these technologies being newer and really well supported, especially on the forums, like I got to do a little shout out for my friends at Daily and Pipecat. They're very active in the community and they're able to respond, and their libraries are like maintained constantly. So if you have support needs, just go to them. And
did you hack together with them over this past weekend?
No, I have never.
They built something for you. You never met them before this weekend?
No. So I used Daily while I was at a previous company, and we had interacted with Quinla before.
Yeah.
But I think the most interaction I have is like GitHub issues.
Yeah.
I would put up a GitHub issues, and magically, like a week or 2 weeks later, it'd just be fixed.
Yeah. Cool.
Yeah. So back to the original question of the different technologies I was using.
The challenges of the
challenges.
yeah.
So software comes a little bit more naturally to me due to my background, but I think the hardest thing was iterating on hardware. So building a project that's end to end from all the way from the front end all the way back to a flying machine, the hardware iteration time takes way longer. So I'm not that familiar with NVIDIA's stack, so it takes a long time to debug their firmware, rewrite new kernel drivers, stuff like that in order to get it to work the way you want it to work.
Yeah. And you designed a unit. You had to design the drone itself to take the payload, and this wasn't an off-the-shelf unit, right? The aerodynamics or the flying properties of the whole thing. You had to design that, right? I'm sure there were kits, but
Very, very roughly. So the frame itself is off the shelf,
Yeah.
and it comes with the motors and everything. But the main consideration you have to make, because drones are well abstracted to the point at this point,
okay.
where the flight controllers are really able to compensate for changes in weight and aerodynamics.
Interesting. Okay.
So it's fairly easy for anyone to get started with the hardware.
Okay. Interesting.
But in order to commercialize it, you need a deeper understanding. So
Sure.
my drone flies well enough to carry a computer.
Yeah.
That's about it.
Yeah. Gotcha.
Yeah, and not fall on people, obviously.
Okay. Yeah. Cool. Now, okay. So you've got voice control with the LLMs. You've got the onboard hardware tracking going. You've got. Did you handle things like it's sort of like autonomously finding its destination? How did you approach that problem?
Yeah. So there's a wealth of APIs available on the internet, like Mapbox, Google Maps, that gives you location information.
Yeah.
So like when you refer to something like the nearest Trader Joe's, or where can I pick up a rotisserie chicken
Yeah,
for
but
dinner?
what about obstacles along the way, obstacles in the sky, whatever that might be, or wind conditions, or like, are you dealing with some of that stuff?
So the main things you have to deal with when you're building a flying object is the where you want it to go. So that's your maps, your weather. There's Google Weather. There's a lot of weather APIs available. Air traffic controls. Their Air Map has a great API for that, and then the FAA. So getting permissions.
What about power lines and trees? As you're just flying high enough that you don't care, or do you deal with that?
So I wasn't really focused on that because there's a lot of companies who have solved real-time object avoidance.
Okay.
My focus was to just fly as high as you can to avoid things, but low enough not to hit anything.
So that you could play with the other aspects of the system overall, like the voice controller.
There's still basic avoidance built in, but a lot of that system, they're available off the shelf. There's libraries.
Are there like open source systems that you could actually use if you want to do?
Yeah. So there's the control library that most people use is called PX4. It has a lot of built-in functions that allow you to do a lot of visual inertial odometry, which is just localizing the drone, obstacle avoidance, safe landing zone finding, and you don't have to worry about that much. You plug and play and it works.
Have you open sourced any part of the project that you've worked on, or contributed back to some of these other systems?
No, I have not. So I was trying to make some PRs for Pipecat to give them a little hand up, but I think eventually maybe I'll open source some parts of it because I do want to encourage people to develop their own thing. But I don't think I've created anything particularly new that people should build off of.
Okay. Well, I mean, it's pretty novel to see a semi-autonomous drone that's voice controlled. I haven't seen that before. That seems novel.
There are other voice control systems out there. When I posted on LinkedIn, someone reached out and posted their open source version of this, that they've already done this before. I think I'm just the first one to make a pretty video about it.
Sure, I mean, at the end of the day, what's great about some of these systems, they're not that hard to put the pieces together. There's a lot there, but there's so much that you can build off of to make wonderful things. You might be too young, but do you remember Taco Copter?
Taco Copter? I've heard people talking about it. It's like some delivery thing that
I think it was almost like I think it was fake. I think it was this person, Star Simpson. She's like an MIT person, and she created like a great concept, and the name is great and stuff like that. It kind of went viral for a bit, but the idea was just, I think it was back during the day of like Uber was just a thing, and it was pretty big already. Drones were there, but not really used, and no one ever really talked about them for delivery, like Amazon. That was way So it was like, I'm going to build Taco Copter, and I'll deliver tacos to you anywhere in the city.
Actually, when I was applying to MIT in high school, I built a VTOL, like a vertical takeoff and landing wing that was super efficient, and I designed it specifically to deliver 20-piece chicken McNuggets because that was like the snack I would get after high school all the time. So the weight constraints and everything, it was designed to just deliver chicken McNuggets.
Awesome.
Yeah.
That's pretty cool. I mean, it seems like that stuff is coming technology-wise, but regulations are the harder part of that.
Regulations are always lagging the technology. That's just how it is in the country.
Well, that reminds me of, you did have another video I saw with the fire scene of like checking out the fire and all that stuff. And like that's a place I think my perception is, you can correct me if I'm wrong, but like drones are, like all the drone startups that were there, they seem to have gone after that market because that's where like first responder scenarios are, or wartime scenarios. Those appear to be the two ones where there's actually, they can get some some traction, I guess. And
Yeah, so the main thing to, prove anything to the FAA or any government agency is miles flown, right? You want to demonstrate reliability and you want to demonstrate like efficacy. So I think the best way to go about that is what Zipline or what Paladin or other Aerodome, the DFR programs are doing. You're under a controlled and necessary scenario. You are deploying these drones, accruing a lot of miles, experience, technology. And then once you've reached a stage of maturity, then they will allow you to start delivering tacos to normal people.
All right. So if somebody wanted to get into like hacking drones and doing this kinds of stuff, where would they start?
Right. I really recommend, there's a lot of great videos on YouTube teaching people how to make drones. Joshua Bardwell is a personal hero, RC Test Flight. All of this started because of people on YouTube building stuff. So
cool.
Just watch YouTube videos, start building your own stuff. And I think hardware is so affordable and accessible these days that you can just put any Raspberry Pi on a computer on a drone and it'll fly and do everything you want it to.
Yeah, super cool. What's your background? Like, how did you get into this?
Sure. I've been flying drones since like middle school. I started with a YouTube channel called Flight Test, and I saved up so much money to fly their little foamy wings. And then from there, I just started building on top of this and building more drones, getting them smarter. Then I worked at Paladin, which is one of the first DFR companies. They send drones to 911 calls. And I think a lot of the industry experience comes from there.
Yeah, makes sense. How many drones have you personally lost?
I have a wall at home of all the corpses of drones that have crashed into things, especially when I got it started because I built everything myself and the flight controllers were harder to use back then. Most of them never even made it off the ground. It was up and then straight down into the ground.
Funny. So you were really building. Yeah,
Yeah.
Okay, cool. And to create Dispatcher, like when did the project get started? Do you have a specific vision in mind for like things you wanted to build in that system?
Yeah, so this is the example I used during the hackathon, but like everyone wants to be Iron Man, and you want like in Spider-Man or stuff, there's always like a drone or a pet bird, something. People have always imagined having a flying personal assistant. So I just wanted to see that come into reality, and then I just wanted to build something that gets as close to that as possible.
Yeah, awesome. What's your biggest wow moment that you had developing this project?
I think it was finding PipeCat, actually. I tried to build the entire, like a PipeCat system all by myself. So it would ingest voice, parse it into an LLM, do function calling, all that. But then I realized that when I was trying to get the real time to work, like in order to be able to, the main thing was interrupt the talking.
Sure.
That's a huge thing that OpenAI, PipeCat was able to do. So once I picked up their library, I was like, oh my goodness, this could go to another level.
Have you looked at the OpenAI real-time voice APIs?
I have not, and I'm very excited to try them.
Yeah. Do you think it has, from what you've seen at least, does it have the extensibility and the sort of hackability to go and do tool calling in the right ways that you would need, or to offload some of the processing like you're doing? You think it could be a drop-in replacement for what you're doing, or?
I don't think it would be as simple because a lot of my framework is built around using PipeCat as a message passing system. And while it can do function calling, in order to like integrate adding, because I don't know if the real-time voice API, I don't know if Vision's already built into that, because I want it to maintain context of not only what it sees, but also what I'm telling it.
Yeah.
So
makes sense.
Yeah, because you gave it a mission and now it saw something and I want it to act based on the mission.
Yeah, I don't know if I don't know when this video comes out, if it'll still be true, but I don't think they've quite released that piece of it yet.
Right.
But I know that PipeCat, you can stream frames of images.
Correct.
And you're using that for the visual. That's really cool. What the frame, like how many per minute or how many per second are you?
It depends. So a lot of the answers to these would be like, it depends, right?
Yeah.
So if you ask it to what it sees, it will tell you, but there's also other scenarios where you want it to continuously ingest images. Yeah.
Okay. And you kind of control that, but what's the max like frame rate that you can get?
Frame rate, I think that's completely limited by OpenAI. You can parallelize the frame calls, so you have several agents.
Yeah.
But I think the maximum throughput you could probably do with one is 1 image per 3 seconds.
Got it. Oh, because when you're getting down to at the end of the day, you were using OpenAI at the provision model once you get
correct.
Yeah.
So if I had more
you're not
compute,
just trained on PipeCat.
No.
Okay.
No.
Got it.
It's OpenAI.
Interesting. Yeah.
Vision transformer models are heavy. That will constraint will always be there.
Yeah, that's pretty cool. How much does it, in terms of tokens used, and what does a flight cost for an hour?
An entire hour. So the drone can go up to an hour. I don't think I've ever like pushed it that far. I think the most a flight has ever cost is like $5.
Yeah.
but that was like really, really pushing it with as many images and parallel function calls and everything.
Sure, yeah. So that'll be a nickel by next year or whatever. But it's good to know. It gives you a sense of like how many tokens are being used.
Correct. Yeah. So it's still way cheaper than hiring a human pilot.
Well, of course.
That's for sure. But if it costed more, there'd be no point. But
What else are you tinkering on? Like, what are some of your other side projects?
I think this might be the only one at the moment. I go-kart and play volleyball, but I think all my free time, the little that I have, is going towards this project.
I mean, there's a lot there. I'm not surprised to hear that. It's a great project.
Yeah.
So, hey, it's been great to have you on. If there's anything else you'd like to share?
Yeah. Oh, actually, one more thing. I'm gonna do a little plug for myself. Yeah, this Dispatcher is just kind of a passion project right now, but I've been approached by a lot of people who say that it could be interesting and people want to use it. I am actively looking for a co-founder.
Nice.
And anyone who wants a demo, who wants to see how the drone works, I would love to talk to them.
That's really cool.
Yeah.
You can help there. That's awesome.
Awesome.
Super. Great to meet you, and thanks for spending the time.
Thank you.
Drone is airborne. What are your next instructions?
Can you go and take a look at what the parking situation is like at the nearest Trader Joe's?
Drone en route to the nearest Trader Joe's.
There it
Will
goes.
inform upon
Point the camera down 30 degrees.
camera tilted down 30 degrees. Will notify upon arrival at Trader Joe's.